coordinates, which is another system to represent eventually functions, right? And ways to represent relations between two things. And instead of what we're used to of an XY plane, which focuses on a left right, a horizontal component, and a vertical component as a Y value, we're going to focus on two different ways to measure how to get from point A to point B. And that is a direct distance and a certain angle or certain direction. So I drew our unit circle here, and what I'm thinking about is like if instead of like focusing on this point as an arbitrary point x comma y, what if I instead focus on another way to describe how to get to that exact location? And I know that there's an x component, which we had already mentioned is a horizontal distance, and a y component, which is a vertical distance. But let's talk about the actual distance from the origin to that point. And I'm going to refer to that distance as an r, or a radius. Kind of makes sense because we're in a circle. And I'm also going to refer to this angle that that radius makes with the positive x-axis, or where we normally put 0 degrees. So instead of calling that point x comma y, I'm going to start thinking about it as r comma theta, where r represents the radius from that origin, and theta represents the angle that's formed in a counterclockwise direction from 0. And just right here by this picture, we get a lot of ways that x, y, r, and theta are related. For example, the Pythagorean theorem is certainly, hopefully, an obvious one. X squared plus y squared equals r squared. So this is going to be important when we start translating or interpreting different ways to represent rectangular versus polar points and functions. And then the other two main ones that are important are thinking about just like right triangle trig. Like if I think about in that triangle the sine of theta, I would think of that as y over r. And I would think of cosine in a similar manner as x over r. And if I multiply the r through to both sides on the first equation and the second equation, I get two more relationships. I get y is equal to r sine of theta, and I get x is equal to r cosine theta. Those are also going to be really important. Um, and then I guess one more that we could probably include here is just like the tangent of theta in that triangle could always equal the ratio y to x. So these are things that we're actually going to keep track of in our notebook. And so I believe I put a spot right here. Oh, yeah. So when we start thinking about the translations, we know that every x can be thought of as an r cosine theta. Every y can be thought of as an r sine theta. We already know that r squared is equal to x squared plus y squared, and tangent of theta could be thought of as x over y. Now, when we start to move away from an xy plane, we don't really have the origin anymore, but we need a starting point. So like the starting point of every polar plane, we'll talk about as being the pole. And it's like 0, 0, except for we don't have x's and y's. So it's the pole. Okay, now the thing about polar coordinates is that they're not unique. Oops, spoiler alert, there's a. They're not unique. And there's also a sense of direction, like with negatives. And negatives doesn't even have to be just negative angles, it can also be a negative radius. So thinking about going backwards, like in a negative direction, is another way we can think about measuring that distance. So I'm gonna start plotting points, and just like I just erased, I guess I didn't need to erase that, but we've got r comma theta. So I'm gonna graph this point 120 degrees with a radius of 8. So we always start at 0, like this is our 0 degrees, just like we have for just our xy or our unit circle, and you're going to go 120 degrees. So 1, 2, 3, 4, 5, 6, 7, 8, and there's A. It's 8 units away from the origin or the pole, and it creates a 120 degree angle. Okay, so let's plot -6, comma 75 degrees. Well, let's see. 75 degrees sits here along this ray. That's 75 degrees. But I want to go a radius of -6. So I'm actually going to go behind that behind that direction. So 1, 2, 3, 4, 5. So it's actually way down here is where I'm going to put B. So it's behind where that 75 degrees is. So that gets plotted there. Now for C, 4 comma -210 degrees. So I'm going to think about going a negative degree. So that's a clockwise direction. So I'm going -180. There's -210 degrees. And then I go out 4 in that direction. 1, 2, 3, 4. So there's where I could plot point C. Let's take a look at the next one. -10, -90. So they're both negative. So even though it's like r comma theta, I really think it's easier to find your theta first. So let's look at -90 degrees. So -90 degrees is down here, right? This is -90 degrees because we went in a negative direction. But now I need to go -10. So I'm going backwards, and I'm going to go in the exact opposite, the exact 180 degrees opposite that. So -10 becomes 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, off the page. -10. So up there is one way to represent -10, or sorry, that -10 comma -90 degrees is one way to represent that point. It's not unique. I could have easily gotten there by doing 10 and 90 as well. Okay, so that's D. Let's go to E, 0, 2, 31. Well, a radius of 0, and it doesn't really matter what your angle is. A radius of 0, you are still going to be at the pole, right? So there's E, 0, 231. Face 231 degrees and go nowhere. And then the last one for F, we have 6 comma 0 degrees. So 0 degrees, remember, is on this right here. We count out 6, 1, 2, 3, 4, 5, 6, and we put F right there. So really the point of that example is just to get used to going forwards and backwards with a radius, as well as with an angle, which we kind of already know. Okay, so it asks us now to give two polar representations of these points. So what I would suggest is to pause this video and try it without me leading you through it, and then fast forward to the end and see if you did it. So good luck. Okay, so hopefully you've had a chance to do that. And so let's take a look to -2. So 2, -2 geographically sits there. Makes a 45, 45, 90 triangle. But if I'm thinking about that for a polar, I could think about it as a radius of 2 root 2 and an angle of 315 degrees. I could think of it as 2 root 2 with a radius of, sorry, with an angle of -45 degrees. I could also think of it as -2 root 2 with an angle of 135 degrees. Remember, you sort of point exactly 180 degrees away and use a negative radius. Okay. For part B, -8, -8 root 3, you've noticed makes a nice 30, 60, 90 triangle. That's 16 away. And if this is 8 and this is -8 root 3, we're looking at one possible way to represent that is 16 comma 240 degrees. Certainly you could do -16 60 degrees, right, because you're 180 degrees away and you go backwards. Or you could say it's 16 comma -120 degrees. All three of those could represent that point. Okay, and then the last one, 0, -7. So we're sitting down here at the South Pole. So one way to represent that is a +7 with a radius of 200, or with a degree of 270. We could also say +7 with an angle of -90, or we could say -7 with a radius of +90. Again, your +90 is on the top, and you're going backwards. Okay, so then the last example that I want to do on this video is going the other way. Oops, I think I did those. So just going back and giving a rectangular representation. So again, I would suggest maybe pause the video. Can you do this? And then check it at the end. So hopefully that makes sense. Okay, so the thing about rectangular representations is those are unique. There's only going to be one answer, even though from a polar perspective, there's multiple ways to get there. So 6 comma 315. So you go 315 degrees, you go out 6. Well, that's a 45, 45, 90 triangle. So that has to be 3 root 2, negative 3 root 2. Next one, 150 degrees with a radius of negative 2. So remember, 150 degrees goes out in this direction as a 30-degree angle, but a radius of negative 2 goes behind it. So that's a distance of 2, and that's a nice 30, 60, 90 triangle. That's negative 1, and that is root 3. So the only way to represent that point geographically is with a rectangular representation is root 3, negative 1. Okay, and then our last one, I guess we'll use this nice blue here, negative 300 degrees. So we're at a 60-degree angle up here, and this is a radius of 2 root 6. So we're in a 30, 60, 90 triangle. So if you think about like the ratio of a 30, 60, 90 triangle, it's x, 2x, x root 3 in this orientation. So if my 2x is equal to 2 root 6, my x must be root 6. So I know this distance down here is root 6. And then if I just know that this would be x root 3, so whatever root 6 times root 3 is, which is root 18. So the coordinates would be root 6 comma root 18 or root 6 comma 3 root 2. Okay, so hopefully that makes sense. Again, just getting the idea of representing a point using its radius and theta as opposed if it's x and y. And then in the next video, you'll see how to convert an entire equation as opposed to just a point at a time.